Hi everyone, welcome. So in this today's video, we are going to see an easy trick to find the hybridization of central atom in a compound. So here are certain rules which can be used to easily find the hybridization of central atom. The first rule is that you have to count all the sigma bonds and lone pair present on the central atom. Sigma bonds mean you have to count the single lines around the central atom, and lone pair means the two dots. And when it comes to lone pair, these are the three elements having lone pairs. So arrange the three elements in the increasing order of atomic number, like nitrogen with 6, nitrogen with 7, oxygen with 8, and fluorine with 9. So this correction needs to be noted. And as you can see, while arranging these elements in the increasing order of their atomic numbers, it is easy to find the lone pair count. Here it is 1, here it is 2, and here it is 3. So in the increasing order, you can write the lone pairs. And when it comes to fluorine, it is representative of halogen family, which also has chlorine, bromine, and iodine with the same lone pair count, which is 3. Now the second rule is that you have to ignore all the pi bonds and positive charge, if any. Pi bond means in a double bond, if you have, this is a double bond with two lines, the first line is sigma and the second line is considered to be pi. And in a triple bond, the first line is as usual considered to be sigma and the remaining two lines are pi. So the additional lines are considered to be pi bonds. So the pi bonds are never to be considered while you are calculating hybridization or while you are finding out hybridization. And if any positive charge is also involved in the determination, that also needs to be ignored. Okay, so the third rule is that take fingers which is equal in number to the above count, which means in the second rule you do not count anything. In the first rule you are counting, which means the first rule itself will give you the total count, and as the total count you have to take that many fingers so that you can start counting. After taking fingers equal in number to the above count, you are done with rule 3. Now let us see what is rule 4. In rule 4 you can start counting from S. So after taking the fingers like this, you can start from S. P1, P2, P3. Why P1, P2 and P3 only? Because there are only 3 p orbitals. And when it comes to d orbitals, we are having d1, d2 and d3. In spite of having 5 different d orbitals, we are taking only 3 because of the geometries and coordination numbers. So that we'll be learning later. For the time being, you need to know that only up to d3, I mean only up to the maximum count of 3 d orbitals are taken for hybridization. Now once you get the count with the fingers, you will be, you are making use of this table. If you have 2 count, take 2 fingers, start from S and then P, you will get SP, like that. If 3 fingers are there, then it is S, P1, P2, so it is SP2 hybridization. If it is 4, the count is 4 means 4 fingers, and you will be counting S, P1, P2 and P3. All the 3 p orbitals are involved, so it is SP3. And if it is 5, S, P1, P2 and P3, and finally you will have to take the other one, which is D1, so it is SP3D. And if it is 6, then you can see this one is S, then this is P1, P2, P3, there is no P4, this is D1, this is D2, so it is SP3D2, and similarly when it is 7, it is SP3D3. And let us see some examples. We are making use of these examples, we are making use of these rules to find the hybridization. So these are the examples to be used for finding the for finding the hybridization. So here it is, single lines are to be as considered as sigma bonds. So as you can see, there are 4 sigma bonds, mean it is 4 sigma bonds, there is no lone pair. So you can see that this is 1, 2, 3 and 4. So S, you have to start with S. So it is S, P1, P2, P3. So the total number is 4 means SP3. You can this way find using fingers. And after the finger calculation, this table has been made. So as a a quicker way of recognition, you can memorize this table as such. So since the number of fingers or the count is 4, it is sp3, which means this carbon is sp3 hybridized. And when you talk about this molecule, which is ammonia, there is one sigma, another sigma, another sigma, and one lone pair. So altogether it is 4. I mean, lone pair has to be considered for finding the hybridization. So altogether it is 4. 3 sigma bonds and 1 lone pair means altogether it is 4. So again, hybridization is sp3. And next example to be considered is water, which is H2O. As you can see here, you can see this is sigma bond, this is sigma bond, this is one lone pair, this is another lone pair. Why I have taken 2 lone pairs? Because oxygen is having 2 lone pairs, as we have already seen. So altogether the count is again 4. So the hybridization of oxygen is sp3. And one more thing, how to find the central atom in a compound, or in the molecule of a compound. The central atom will be lesser in number of atoms. I mean, if you are taking H2O, the central atom is oxygen, which is 1. Oxygen is only once occurring, whereas hydrogen is occurring twice, which means whichever is less in number is considered to be the central atom. As in most of the cases it will be like this. Next example is BF3. It is boron trifluoride. Here you can see sigma, sigma, sigma. Here only 3 sigma bonds are involved, which means hybridization is sp2. How do you find that it is sp2 hybridized? Because 3 fingers means you have to start counting from S, P1, P2. Your fingers are ending up with P2, which means hybridization is sp2. I hope you understood. Now this is carbocation, which means there is a positive charge which needs to be ignored. And this is sigma, this is sigma, this is sigma. So 3 sigma bonds, pi, there is no pi. There is a positive charge which needs to be ignored. So again the hybridization is sp2. And in this compound, as you can see, the formula is C2H4, which means lesser in number is carbon. So these 2 carbons are acting as the central atoms. So if you take this example, you can see there is around this carbon, there is one sigma, another sigma here, another pi here, another sigma here. So 3 sigma bonds and 1 pi. Pi needs to be ignored, which means 3 sigma bonds means hybridization is again sp2. And this carbon also similarly has sp2, because these 2 are also sigma and this is also sigma. So 3 sigmas and 1 pi. Pi needs to be ignored. Again, here you have an example of carbon dioxide. So this is the central atom, this is sigma, this is sigma, this is pi, this is pi. So if you take this carbon central atom, you have only 2 sigma bonds means, and pi bonds are ignored usually, right? So 2 sigma bonds means 2 fingers, and you have to count from S, and you are getting sp hybridization. So the carbon atom in carbon dioxide is sp hybridized. I hope you understood today's class. If you have any doubts, you can leave comments, and your questions will be answered as early as possible. Okay, thank you for watching.